Cool.
Cool.
Okay. Well,
Really
Dr.
good questions.
I have to go. I have like a class in about 30 minutes. I gotta kind of get ready for it.
What class is this?
It's physics. I have it at 2:30.
Is that Dr. Jones?
No, it's with Dr. Smith.
Okay, cool. That's fun.
Yeah.
All right, enjoy.
Okay. All right. Thank you.
Yeah, bye.
Bye.
Hey, Dr. Ismert,
What's up?
could you do number 5 on 11.5?
Absolutely. I still haven't heard like a peep from Edwin, which is fine. If you're just hanging out, you just do that. Okay. 11.5, number 5. Test the series for convergence or divergence.
Yep.
Okay. So ooh. Okay. Okay.
I thought you could sort of assume that this function was similar to 1 over n squared.
Because you have like n over n to the 3/2.
Right.
And that's 1 over n to the 1/2, which diverges.
Right. But that's wrong.
So the thing that makes this converge is this, is the fact that it's alternating.
Oh, okay.
Yeah. And I like the way you're thinking, but this is what's so weird about alternating series is that this converges even though 1 over n diverges.
It's actually what I originally came on here to talk to you about.
Okay.
Then I just assumed that it was because it was alternating it converges.
Yeah, that's all.
But how do we prove it?
Diverge if it weren't alternating.
Yeah, I was gonna ask you to like show how that works.
Sure.
Yeah.
Yeah, definitely. So, okay. Sorry. I feel like I need to burp. It's like built up. It hurts. I'm gonna have like a heart attack right here on my office hours. Okay, so here's what I want you to think about. So is it okay if I just play with these two?
Yeah.
As this example. Okay, so 1 over n, if we think of it as an area, we're thinking of like adding up these rectangles of height 1, 1/2, 1/3, 1/4, 1/5.
Right.
Right? Okay. So that's the area for those. But then if we look at the alternating version, okay, if we look at the alternating version, we start up here, right, with our A1,
right.
but A2 is like down here. It's a negative area. And we've got A3, then we've got A4, then we've got A5, then we've got A6. And so this alternating area ends up canceling each other enough that the limit goes to 0. And here's another way to see that, Spencer. Oops. Connor, I don't know if you intended to mute yourself. It looked like I muted you, but if you want to be muted.
Yeah, I was trying to mute myself so you didn't get any.
I unmuted you. I was like, no. Okay, sorry. Okay, so Spencer and Michael, here is, you know, kind of a picture of an alternating series. You've got some positive terms, A1, A2, A3, A4, and you just add and subtract them back and forth, right?
Right.
Okay, so basically, once you go out, let's say maybe we've added up these first terms. Let me write that as S sub 6. The, what do I want to say? The actual value of your series, your alternating series, minus that right? That's going to be all of these terms that come afterwards. Does that make sense?
Okay, yeah.
Yeah, so I'm just I got the whole sum minus the first part of the sum, and that's going to leave me with the tail, right? Everything that comes after. Okay.
Yeah.
All right. So the idea is so long as these terms are going to 0 and they are decreasing, then the largest that this difference could be would be A7. Does that make sense?
Yeah.
Okay, because the moment you have A7 minus A8, you've taken a chunk out of A7 that you'll never get back because A9 is not as big as A7. Does
Right.
that, okay? So once you start alternating past A7, you never get back to that size again. So
Okay.
the fact that this inequality is satisfied, and if you know this, yeah, then you know, here's like the more general form of this. If you have the nth partial sum, you're always less than or equal to a sub n plus 1. And you know that this goes to 0. So basically what that says is these partial sums converge to this finite value. It's really this collapse, this inequality, Spencer and Michael, that make something different than the positive version. I don't know if that
Okay.
helped.
But because a sub n goes to 0,
Mm-hmm. That's usually not enough, right?
right. So now that we have a sub 7, we now know it does exist.
Right. That these partial sums actually converge to a finite value. That is the actual value of this series. Oops, a sub n. Yeah.
And so that converges.
Mm-hmm. Right. And so I guess the big difference here is if we tried to do this instead, if we took the sum from n equals 1 to infinity of just a sub n without the alternating part, just a sub n minus s sub n,
Right.
right? This is all the terms that come after a sub n. S sub n is the sum from a1 to an. But if it's not alternating, this thing's just getting bigger, right?
Yeah.
This doesn't have an upper bound like an alternating series does.
Okay.
And that's the issue. Does that help, Spencer? Or is that just more confusing?
Yeah, no, that makes sense.
It's pretty theoretical, but I think just feeling like areas getting cut off, it's getting canceled out, that's helping a lot.
Got it. Thank you.
Yeah, you're welcome.
I'll talk to you later.
Okay, bye-bye.